Welcome to the overview session of what's new in Beyond Relational Functionality to manage unstructured and semi-structured data in SQL Server 2008. How many of you have attended Setu's presentation on file streams today? Okay, Setu told me that since he didn't know that my talk was following later, he already talked lots about what's new going to happen in terms of beyond relational functionality, beyond what he was planning on doing. So I apologize for those people that may see some overlap here. Please don't give me bad remarks in my bad review scores, because that was not planned to have been inverted in the presentation style. That was something that we only realized when we saw the program a little bit too late. However, I will cover other stuff that he has been doing. So for example, I will cover FileStream in the beginning, but using a couple of different slides than him. I will then go into more details on some of the beyond relational functionality. So I think there should be enough new stuff to make it worthwhile to attend both sessions. So let me introduce myself quickly. My name is Michael Rees. I'm a principal program manager in the SQL Server Relational Engine team. My responsibilities in the team include, among other things, query languages such as XQuery SQL, beyond relational technologies, including, for example, XML. So, and I'm basically have been presenting here a couple of presentations about spatial, of which I own the spatial indexing. And this will be my last breakout session at the conference, where I'm going to talk about the new beyond relational functionality that we are adding at a more overview level. So the objective and the agenda of the presentation is that you will understand what SQL Server 2008 will offer in addition to what 2005 already offers in order to manage and store unstructured and semi-structured data. Let me quickly define what I understand with unstructured and semi-structured data before I continue. Unstructured data is data that the database by itself only sees as a large blob. It has no interior knowledge about the structure of the data inside. It doesn't mean that the data itself doesn't have any structure. For example, if you take a JPEG image, a JPEG image has a header information that contains so-called EXIF data, which records, among other things, what type of camera you were using, what type of exposure you had, what type of aperture you were using when you were taking the picture. That's all structured information. However, when you store that as inside the database, we don't have a JPEG type. We don't know anything about that structural information. So for the database perspective, it's unstructured. Semi-structured means that the data that you're having has some structural component. It is still data. It's not documents, in the sense that order is not important, for example, that you have the structural component information, like what is the property name, and the value need to be together to provide you with semantics, while in documents you can read Hamlet even without markup in it. So that's kind of what I understand on the semi-structured data. Also, one of the goals that I have is that in some cases where we have overlapping technologies covering similar use cases, and you could use one or the other, that you kind of have an understanding of which one of these two technologies you should be using. Please come in. There are a couple of free seats left here in the middle, and on the front row here, it's all free. Good. So this slide you already have seen. And the reason why I repeat it, for those that have attended Setu's presentation. The reason why I repeat it is because the pain points are exactly the same. Basically, you have more and more non-relational data that you need to manage. And so you need to understand how to deal with that in conjunction with your existing line of business application data that you have in relational databases. Also, the growth in the complexity of your applications and the duplication of functionality across tiers, etc., need to be dealt with. So basically, the goal is now that we reduce the cost of managing all types of data, simplify the development of the applications, and extend the existing services with support for non-relational data as well. Meaning, for example, that you have transaction management now not only running on relational data, but that you have transactional management that also helps with, for example, unstructured data. So we haven't been really starting with beyond relational functionality just in SQL Server 2008. We actually already had functionality in SQL Server 2000 and in 2005. So we have a couple of categories here that I show. One is the XML category, which is where we did a big investment in SQL Server 2005, introducing XQuery, the XML data types, schema collections, etc. Then in document and multimedia management, we had full text indexing that we greatly improved performance and scalability in 2005. And we had, in the relational context, we introduced something that we called user-defined types, which was based on CLR, and user-defined functions, which allow you to actually extract structures out of the blob if you don't have any other ways of accessing it by, for example, parsing the binary, analyzing it, and exposing it through, for example, a user-defined table-valued function. In SQL Server 2008, we are adding additional functionality to the XML area. And I will show that with demos during the presentation. We are also improving our area of document management quite considerably. We are adding the file stream property. We are adding remote blob storage. And we are moving the full text indexing capabilities from that external component into the database. And that's a major undertaking. And I will show you what the benefits are of us doing that undertaking in this release. A very cool new feature for which I had a separate breakout talk yesterday morning is that we have added support for spatial data. And I'm going only quickly to go a little bit, give you an overview of that and refer you to that other presentation. On the relational data side, we have added lots of support for managing semi-structured data by means of flexible columns, white tables, hierarchies, IDs, etc. And I will give you examples of what that is and when to use it and how to use it. So let's start with the unstructured parts. Unstructured, there are different ways of storing unstructured data today. Here you see three. One is you put it into file servers. That's kind of what most of us probably do. We put our large blobs, documents, etc. into file systems because that's the most efficient way of accessing it. And if you don't do any updates to it, who cares about concurrency control, etc. Another application is sometimes if you really need high performance and scalability, you go with something like dedicated blob storage. However, the disadvantage of that is it's normally very expensive, and you have to basically have support staff for it to actually manage these instances, etc. And so the application development and deployment for that is quite complex, and it's quite costly. The third alternative that people have been using is, well, let's just use the database and put it into the database. Now, obviously, the drawbacks there is that we don't have data streaming support, which is the kind of reason what you would probably want to do with many of your large unstructured documents that you want to stream over the web, etc. And it has the highest cost per gigabyte because you have the whole database overhead on it, etc. Now, some examples for these are file servers. Obviously, we have Windows file servers for the dedicated blob store. We have things like EMC Centera, etc. And in SQL Server, we have var binary max for storing the blob data. Also, there are size implications, like var binary max currently has a maximum size limit of 2 gigabytes. So what are we doing in SQL Server 2008 to kind of address this area? We have added on one direction in remote blob storage, we are adding additional support to abstract blob storage APIs and allow you to basically integrate data that you have in the blob storage into your database environment. And I think Setu showed that in his presentation. We also are going to supporting the notion of a file stream over your blob data that you have inside your SQL Server, which gives you the ability to store larger documents than 2 gigabytes and have a streaming access mechanism to the data that you have managed through the database using the file stream attribute. So what is file stream exactly? File stream is a storage attribute on var binary maps. So it's not a type per se, it's a storage attribute. That means that all the operations that you're normally doing with var binary maps, you can still do on this. However, you are not restricted by the 2 gigabyte limit size for the data that you're storing inside such a file stream object. Note that you need NTFS. However, we are not using NTFS transacted file system, so you don't have to enable that. And you will have a dual programming model against the data. So beyond the T-SQL programming model that allows you to do whatever you can do with nvarchar max, you also have the ability to go and use Win32 API. The only addition that we actually provide you with is an additional small layer that gives you a file handle back for such an object. You also have, therefore, guaranteed data consistency. You will have backup restore that can deal with file streams like any other database partition that you will be able to do backup and restore with. And you have the whole SQL Server security stack that gives you access control, etc., against the data that is integrated with the access control that you have against the other data that you have inside the database. Now, there's more detail in Setu's presentation. For those that haven't seen it, I recommend that you go and download the slides and potentially even the video later when it gets released on the website. Remote blob store API, basically the goal there is that applications can transparently support different blob stores. Today, every vendor has its own API, and so basically this is kind of giving you the ability to abstract the API, and not only abstract the API, but to have SQL Server understand that abstraction. And then every blob store vendor, if he wants to play in this community, will provide a provider that then works towards that API. And again, for more details, I refer to Setu's talk about file streams earlier today. So now let's look at, so far we have looked at the storage and management of unstructured data. Now, sometimes you also want to search your unstructured data. And in SQL Server 2005, we already had support for full-text indexing. We actually did quite a bit of performance and scalability improvements at the time. However, due to the fact that the index was still stored outside of SQL Server 2005, there were still certain manageability and security and performance concerns that people had. So what we are basically, also one of the issues, for example, in terms of performance was that if you were running a query such as find me all the documents that contain a certain phrase and where the author is XYZ, even though I had an index on author and could identify only the documents that the author requested, I did not have a mechanism of communicating that to the full-text index, so the full-text index would still give me back all the documents that contained that phrase I was looking for. So I was basically doing way too much work in doing the lookup on the full-text index, and therefore I didn't have as good as a performance as I could have if the indexes actually would know about each other. And my apologies, this thing here seems to be on auto move. Probably telling me that I should move on. Other issues that we had, if you had really large boxes, there were scaling issues with this external index. So what we have been doing now is that we have actually integrated the full-text index into the engine. So the obviously benefit is now that all the things that have been external, like the index, like stop words, are now managed within the database. That leads to better performance in many common scenarios. It makes this mixed case query better performance scale. The optimizer has now knowledge about what's inside the full text index. So for example, this query that I was explaining earlier, in this case, I'm looking for candidates that have a resume containing SQL Server and are in the Redmond zip code in the US. Now, I can actually make use of that information and only really look at the documents that are associated with that zip code for doing the full text search. Also, the full text index content is exposed, and the word breakers are better supported, and we have more of them when we ship. Basically, they're about almost twice as many by the time we are shipping than what we had in SQL Server 2005, which some of the European languages will be happy about. Now, having done that, I'm going now to talk about, having completed the section on unstructured data, let me now move on to like what we have done in the kind of semi-structured context and so on. One thing we have done in SQL Server 2005 is that we have added large UDTs. Large UDTs means that your CLR UDTs that you have specified in SQL Server 2005 are limited by 8K. Now you can go up to 2 gigabytes. Conceptually, again, at the storage level, they're equivalent to var binary max. That means that they have a size of -1 reflected in the metadata, etc. And they will be converted to var binary max or image for down-level clients. But otherwise, they are just like CLR UDTs. Now, one of the reasons why we support now large UDTs is so that we can do support for spatial data, because our spatial data types inside the database are implemented using large UDTs. However, they are specifically built into the database, so you still can have your CLR support turned off while you're using your spatial support. The spatial types basically have been added to help bring spatial location-aware application developments to the masses, so to speak. We provide 2 types, both 2-dimensional. One is called geometry, which is for planar data, such as, for example, the floor layout in here. The other one is called geography, which is for geodetic data, such as the whole Earth, longitude, latitude information. We support the Open Geospatial Consortium. Sorry, I'm Swiss. I have a speech impediment. Basic functionality for SQL features. And we have integration with Virtual Earth. There's much more information in my talk that I gave yesterday morning about support of spatial in SQL Server 2008. Now on the XML improvement side, we have done quite a bit of improvements by adding lax validation in the schema support for XML schema collections. This is important because it actually gives support for many of the industry schemas inside the database without you having to go and edit the industry schema, and therefore makes it easier to manage it. We also have improved our support for data time values. In SQL Server 2005, due to implementation restrictions, we could only accept values with a time zone, and we normalized it to Zulu time zone, which is basically Greenwich Mean Time. And now in 2008, we will accept both values with and without time zone. And if you give us a time zone, we will actually preserve the time zone that you have given us in round trip. We also have improved our list of unions and unions of list handling as a side effect. One of the things that people always have missing in xQuery was the let clause. We have added support for the let clause. And we have added support for inserting an XML variable into another XML document. One of the major complaints that we have received online from customers complaining about that they have to go into dynamic SQL for doing that. So before and now probably my demo will just continue to slide on, but I want to show you a little bit in code what we have done here on the XML side. So this is an internal draft version of SQL Server 2008, most of the XML functionality that you see here is already available in the current July CDP. I think the let clause is not yet available. That will be available in the next CDP. So let's look at what we can do here. Let's create a schema collection that contains LAX validated schema. Let's first create it, and then let's quickly look at what the schema actually contains. So the schema contains first an element doc that has a complex sequence of customers, each of which is a customer type. Now the customer type itself has a name, a date of birth, which happens to be a date-time data type. It has a named element nodes, and the named element nodes has mixed content containing in any section with process context equals LAX. Now in SQL Server 2005, this would be rejected by the by SQL Server 2005 because we don't support LAX. You would have to have either strict or skip validation there. Now we also have an order element. The order element has an order date and the ship date, each one of which is a date time, and it has an ID attribute, which is a string. So now that I have created the schema collection, let's create a table customer that contains all the XML information in an XML column using constrained by this schema collection. And now let's add some data. The data that I'm inserting obviously has to be conformant to the schema, otherwise the schema validation will reject it. So in this case, I insert the customer with the name Peter, a date of birth. Now look at the date of birth. It doesn't have a time zone, and it has a very high precision. We also add nodes there with some mixed content, containing also, among other things, an order. And if you look at the order, these two order dates and ship dates have values that have time zones associated with it. And the order actually conforms to the order definition inside the schema, so I should be fine with my LAX validation. So if I just do the insertion here, that actually works. Let me move this up a bit, because the next one will actually give me an error message. Now you could say, well, okay, you now allow LAX, but you just do the same as skip or something, so you're not actually doing any validation. Just to show that we actually do LAX validation, I'll show you an example where we actually get an error message. So LAX validation actually means the following. If you give me data inside that LAX validation section, and I don't know what data you're giving me. If you give me an element for which I don't know what the name is, I'm fine. I'm taking it. However, if you're giving me data that contains a name that I know in my schema, it has to be valid according to that schema. So in the previous example, if you look up, you actually see that I entered the partner there. The partner is not part of the schema. And this was fine. It accepted that. But now, I'm also adding orders, but orders was in the schema, so it has to conform to the schema definition. So in this case, I add an order that does not conform to the schema definition because it doesn't contain the ship date. So let's do an insertion. And voila, it actually gives me a validation error message down here that says the ship date is missing. So this is LAX validation. Now let's look at the new date time support. Let's retrieve the instance that I just have inserted correctly earlier. Now if you look at the data that I have here, you will notice that in the date of birth, I preserved the absence of a time zone. I preserved the resolution. So we have now much better support based on the new date time to and date time offset functionality that SQL Server 2008 will be providing you also in the relational context. And we are preserving the original time zone information that you have provided us with. So this is something that we have fixed compared to what we have done in SQL Server 2005. Now, let's say that I actually want to insert an order into this document. So what I do here is I say declare new order XML and initialize that right away with my XML. How many of you have seen this pattern before? So we have done a couple of nice developer-ish type features in SQL Server 2008 nobody's really talking about. One is that you can now initialize your variable when you type it, instead of having to use a set afterwards. Thank you. I was expecting some applause on that. And so I'm kind of showing some of these throughout my demo as kind of delighters for you guys. So if I now use this variable and I want to insert it into my notes that I already have, in order to be able to do that in SQL Server 2005, I either had to use dynamic SQL, which was rather awkward, or I had to decompose the document and use 4XML to recompose it and then put it back in, which also sounds rather awkward. Pardon? Yes, that's true for all. So the question was whether this syntax that I have highlighted here with the initialization and the declaration in the same line works for all data types. And the answer is it works for all data types where you would have to do it using declaration and the set statement, yes. So it's not only for the XML one. OK, let's go back to the query. So what you can do now in SQL Server 2008 is you can just say insert SQL variable, refer to the XML data type here, and insert it into the node, as it was supposed to be from the beginning, but we had some implementation restrictions that we lifted here. So now if I do this and look at the data, you will notice that I now have added the order over here. So there's the order ID 02 that I have inserted. Now the last item that I want to show you, or the second to last one, is the let clause. The let clause is something that has been part of the xQuery select equivalent for a while, but we didn't support that in SQL Server 2008. The main use for the let clause, as we supported in 2008, is to allow you to simplify your SQL query state, your xQuery formulation. It means if you have an expression that you use in multiple different locations, you can name it now with the let clause. It will not do common sub-expression evaluation. It's a pure manageability, code manageability feature. What will happen is that the algebraizer will take that and insert it at the corresponding reference points. So there is no common sub-expression elimination happening at the moment. This is similar to what the with clause does in SQL, basically. You name an expression. So in this example here is I go for every one of my customers in my document. I bind the variable O to all its orders and the variable name to the name of the customer. Then I have a condition where for some of the orders satisfy ship date equals order date. I then return the result ordered by name containing the name and the order. Now, since I only have one customer in my XML here, the ordering doesn't do much, but it just shows you the pattern that you can use when you use a let clause is, for example, when you have an expression that you use in an order by and in the result, or in this case, if you use the O in the predicate here as well as in the result. Oops, let me select the whole select statement here. Just to show you that it actually works. You see now there's a result named Peter with the order information. Now, when you looked at the date-time data types, you might have noticed that they have different time zones. However, even though they have different time zones, they are still operationally compared based on the point in time on the time axis. And so we still normalize them to a single timeline. And that means that you will still get the expected semantics that you have, mainly that +1, I think 10 o'clock +1 here is the same as 9 o'clock in Britain. Okay, now another thing that I just wanted to show you is with the lax validation. So if I check my partner element that has been inserted inside that lax validation section, that wasn't provided the type information, so that's considered to be any type. And just to show you that this is true, I run this, it's basically, it's not a simple type, it's considered to be a complex type. Because an element per default is complex. So it will say false on this query. However, now let me add a new partner element to the schema collection. Now this affects data that I already have inside my database. So what should we do? Well, we could reject this statement, which we obviously don't, or we could go and revalidate the data and give it a new type based on what I have now just done. So if I now run the query again up here, I'm now getting back true. And actually, I can be even more precise. I can actually check for whether it's a string. And I'm getting back true as well. So this just shows us the kind of stuff that we have done in the XML space. Let me move back to my presentation and talk a little bit about all the big investment we've done to manage semi-structured data in the relational context. This is kind of an overview slide. You don't have to really understand what's going on. This is just kind of showing you the bullet points of what we have added. First, we have added hierarchy ID. That gives us the ability to manage data that represents hierarchy in a relational context. We have added large UDTs that we already have talked about. We have sparse columns, which is the yellow part there, which gives us a more efficient way of managing relational columns that have lots of null values in them. We also have white table support planned, which is the ability to add much more than the 10,024 columns that we currently support if you use sparse columns. Because if you use sparse columns, you often have lots of properties that you are only adding for a couple of rows. So after some time, you're running out of columns. And so you need more than that. So we are now going to support hundreds of thousands of columns, basically, for sparse columns, not for the non-sparseness. We also are adding filtered indices, which allows us to relationally do indices on only parts of the data inside my table. And not only do we support the indices, in order to be able for the cost-based optimization to actually make use of them, we also have statistics that are then applied only to these filtered indices. And I will show you some examples during the demo of that. So what are some of the scenarios that you encounter in the wild when you do semi-structured data management? The first one that we have encountered when we were providing support for semi-structured data using XML is the property bag scenario. In the property bag scenario, you probably have distinct customized properties that are associated with certain sets of data. For example, if you have a shopping cart, you have lots of different items in them. Some of these items have specific properties that are specific to the type of item that you're having in there. Like camera models for a camera is not necessarily applicable to your memory card that you have inside the same shopping bag. Now, there are also often large numbers of unique properties. There might be user annotations, etc. Now, also semi-structured is when you have heterogeneous typed data, such as, for example, type-specific properties, inherited properties, etc. such as, for example, product catalogs, etc. Now, they are related to property bag scenarios. However, it is more structured than property bag scenarios. Property bags are often potentially one-off annotations you have on a specific instance, while heterogeneous record types are more things that are driven off type hierarchy, where you don't want to do full decomposition of your model, but you want to kind of represent the information in a single table. Also, the characteristics of such semi-structured data is normally that you have a large number of sparsely populated properties, meaning lots of null values. Often these property sets are distinct, meaning that one set of types, like cameras, do not share many of these sparse properties with something else, like, for example, pants. They're often heterogeneous in this previous definition, and often there might be sets or nested structures. Like you might have more than one phone number, and numbers of phones might change over time. Now, obviously, this leads to certain requirements if you want to support that. One of the requirements is that you have to have efficient storage for sparse properties. SQL Server 2005 did not do that. Every null value that you put into your database occupied space. So if you have lots of null values, you're still using space, even though you're not recording any information. The other thing is that you still have efficient relational access to these properties. And forget the metadata here for a moment. So you need queries, updates, and indexing against it to be able to efficiently work on them. Finally, you need to have an ability to set and get these properties as a unit, because often you look at them as a unit and want to be able to work with all the properties as a unit and don't want to kind of specifically identify individual properties in your select statement, for example, because your select statement gets huge and unmaintainable. And then finally, and that kind of relates to the indexing mentioned earlier, you also only want to index the subparts of those properties that you're really interested in. If you do an index on camera models to index for cameras, you are not interested in indexing things that are related to pants, even though they might live in the same table. So you want to be able to have what we call partial filtered indices. Finally, when you have hierarchical information, you might want to be able to retrieve that, analyze that, and manage that as well in some relational format. And we have some support for that now. So the features that we have added to address these semi-structured needs are, first, sparse column that gives us optimized ways of storing these sparse properties in a relational form. The second one is column sets and wide tables. Column sets is a mechanism of generically looking at all my sparse columns as a unit, and the wide tables allows me to have hundred thousands of those sparse properties in a table without running afoul of the 1024 column limit. Filtered indices, already mentioned, gives us the ability to only index parts of the data. And the hierarchy ID is a new system CLR type that, again, is provided by SQL Server built in that allows you to deal with hierarchies in some interesting ways. Now, thank you. Some of the features that we have added here allow us to deal with semi-structuredness, but they don't allow us to deal with completely dynamic appearances and disappearances of properties. So even though in SQL Server 2005 you used XML for many of these scenarios, you can still use XML for these scenarios, and XML still has its use in the context of when you don't know a priori what sparse columns you're actually going to get, because since it's a column, you still have to do a create table statement to define them at the time when you create the table. So if you're still having fast dynamic evolution, if you have sets or tree objects, you probably still want to use the XML for managing that. So now let me show a demo of sparse columns and hierarchy ID. Here I basically define a simple products table that has an ID, a type for the product that I'm storing, plus zoom length and resolution, waist size, and inseam. The main difference to existing tables is that each one of these 4 properties here have an indication that they are sparse. So this is basically identifying a column as being a sparse column, which then triggers the more efficient internal storage, etc. So let's create this table. Now let's insert some data. As you can see, the 2 types of data that we're inserting are cameras that use the first 2 sparse properties, and pans, which use the other 2 sparse properties, and they are not really overlapping. We have cameras now in cell phones, but we haven't gotten cameras in pans yet. If you look at this statement, what do you notice? We have row constructors now. So SQL Server 2008 now allows you to write an insert statement using row constructors instead of having to use select, union, alls, and other such things. So applause. OK, so let's insert some data here. And if I ever get used to VPC. Now let's look at what we have. Select star still works as normal. It gives me back all the columns with all the data and shows me the null values here in waist size and zoom length, etc. I can select individual sparse columns normally, like any other column. In this case, I get the type, the waist size, and inseam. And so they just operate like normal columns from a programmability point of view. Now let's look at what I can do with column sets quickly. So let's create the same table, only this time I'm adding a column set. A column set is an explicitly defined column of type XML that has a specific indication that it's actually a column set. So it's not a normal XML data type. It's a column set. It's a computed view over all the sparse properties that I have inside my table. Note that the syntax in this release only allows us to specify all sparse columns. But maybe in a future release, if there is enough demand, we can imagine to extend that to allow a list of column specifications. So let's create this. And now let's insert the same amount of same data that we had before. Note that I here insert the data still into my sparse columns. I'm not using the column set here. And however, now there's a difference. If I select star, if I have a column set, I'm actually not getting my properties back. I'm getting back the properties in XML form. And if you have large amounts of sparseness, this is actually a much more efficient way of getting the data back. But it doesn't stop there. It actually also helps you manage your properties in interesting ways. So let me show you how that goes. I can, for example, insert products now through my column set. So instead of having to outline each individual value, I can pass it in as XML. And what it will do is it will now replace my zoom length and resolution for the camera and adds a new waist size and inseam for that pan. So it has added 2 rows. I can still update individual values directly. So in this case, what I do is I set the zoom length to 12 of this camera that I just inserted here with a zoom length of 10. So let's do this. So I can still address these sparse columns individually, even if there is a column set specified. And I can also individually query them. In this case, I get them individually, zoom length and resolution, as well as the column set explicitly, because it's just another column. And I actually can do this. The comment there is old. So now let's go and update the products with the zoom length 12 and update the zoom length 11 of the product properties. And this is something that I was asked the last time I was presenting this. In this build, it was actually working. However, the good news is that this is not really deterministic. What will happen, which one of the values will be taken. So in the current CDP build, this is actually disallowed. And you actually will get an error message. Yes? So let me repeat the question. We can actually run the code quickly. So the question is, if I do an update set product properties, but instead of specifying all the properties, I specify only one of them, what happens with the other ones that are set? And the answer of that is that it should replace the other one with null. So let's quickly look what happens here. So as you can see, the resolution is set to null. We have planned in some future release the ability to say, I don't care. Leave the value as is. And if that's an important feature, you saw my contact information, my email information is available upon request. And you can use Connect on the Microsoft.com website to give us corresponding feedback. Yes?
Is there any change in the way sparse column is stored?
Yes. So the question was, do we actually have storage engine changes to better deal with sparse columns compared to how we dealt with columns otherwise? The answer to that is yes, and I will show a slide on that in a minute. OK, so here, now we have basically shown you what we can do with column sets. Now let's look at what we can do to improve our query performance. So let's assume I want to have my queries over pants where the waist size is greater than 34. So let's run this query. Let's also quickly show the query plan here. So you can see I get them back in reasonable time. And what takes a little bit longer is get the query plan. And I see I have a table scan here. So now let's create a filtered index for all large pants, meaning I say create index. Oops, let me scroll that down. On products waist size, where types equals pants and waist size is greater than 43. So now I'm defining an index on this column, sparse column, only for the values that satisfy the criterion. Now, actually, the most common filtered index you probably will do is index only the values that are not null. But this is actually showing a little bit more advanced use case. So let's create this index quickly. And now let's look at the query again. Now in this build, I have to still hint the index. I don't know what the status is today, but basically if you look at the execution plan now, you will see that it's actually making use of the plus size pants index up here. Another thing that you might notice is that it now says index seek parentheses non-clustered. Since we have now all these new index types, primary XML index, secondary XML index, spatial index, non-clustered index, full text index, etc., we are now adding that information, what type of index it is, into the title of the icon there, so it's easier for you to recognize it textually what actually the index is that you're operating with. Okay, so that's pretty cool. Now let's look at another interesting example. So one of the questions that I've gotten is Oracle has the ability to define indices on unique indices on columns disregarding null values. Now we can model that using these filtered indices. So let me do a table test here that has an ID that is sparse. I insert 1 null, 2 null, so there are 2 null values there. Oh, I had the table already? And let me say drop table looks test. This happens if you're using a VPC. Okay. Now if I look at this, you see that I have the null values in the ID. Now I create a unique index on this. However, I use a filtered unique index on it. So I say, don't index my null values. And it actually works. And if I execute this, the plan will again use the index that I have created. And if I go and insert a new null value here, that still works as well. So you can see that these filtered indices have applications with sparse columns that actually go beyond the kind of original design that you probably thought about when you heard about filtered indices. So now let me go and show you hierarchy ID. Hierarchy ID is a mechanism for us to encode hierarchy information inside the database without having to use either XML nor parent-child tables. So now you can, one of the problems with parent-child tables is that you have to do these recursive self-joins in order to be able to get all your descendants, etc. And with hierarchy ID, what you do is you just do a scan. Note that the hierarchy ID actually came out of the work that we did in XML to efficiently manage the positioning and order and hierarchy information of XML structures. So how do you use this? Here you have a table org that has a hierarchy ID node. It has a level that is a computed column that is persisted that gives me the node's level. So there's a method on the node that says get level that gives me the level in the hierarchy. And I have an emp ID and potentially some other employee information in other columns. Now, hierarchy ID is encoding information in a way that it allows us to cluster information per default in a depth-first manner. So if I do an index just on the node, I basically order my data in that index in a depth-first manner. That means I first go down the tree, then I backtrack, go down again, backtrack, go down again, and so on, go back up, go back down, and traverse the tree like that. I'm not sure, did I already execute this? Then let's do it. Alternatively, I might want to traverse my tree breadth first. So I go down, I go over, I go down, I go over. I can do that by doing a clustered index on the level and the node. That way, basically, the node then gives me the level gives me the breadth first aspect, and the node then gives me the order among the level. So let me do this. And so this works as well. Okay, now let's look at inserting some data here. In order to insert the root of a hierarchy ID, I use the hierarchy ID get root method, and I insert the first employee into my table here. Let's look how the data looks like. Oops, let me move that up a bit. And you see here that the node is just the binary value. Well, since it's a CLR user-defined type, I have to do string function, and that gives me a more readable representation of the value. And basically, we use kind of slash notation for identifying levels. So the root node is just slash. People familiar with file systems and so on might recognize this. Now let's add a function, a procedure that allows me to insert an employee ID at the end of a manager's employee IDs list. So basically, for a given manager, I insert a new employee at the end of its list. Now this is done by basically providing the manager ID that will be looked up and the employee ID that will be inserted. And what I do there is I basically get, if you look in the begin transaction component, what I do there is I get the ancestor one level down from the node, which represents the manager, and gives me the maximum node number out of those ancestors. And then I insert this into my new value by basically moving it between that last node that I have in the list and null, which basically means at the end. So let's look what this does here. Let's create it, and let's insert a couple of new employees. So we add 2 new employees for employee number 1, and then employee number 2 gets another employee after that. Now let's see how the structure actually looks like. As you can see, we have added 1, 2, and 1.1. And we have here the values returned in breadth first ordering. And you can see that we have the levels auto-computed and the employee IDs as provided in the statement. I can also specify a store procedure that allows me to insert after a given employee. Now, for employee lists, let's say the employees are ranked according to performance or according to the first name or something like that. So in this case, I give not only the manager ID and the place and the new one, I also give the place after which I want to insert. And so this is what this store procedure does. As you can see, the get descendant is the component that identifies the new value that I create. And so there I give the before and after value. And so now let's insert a couple of new ones. And I happen to insert them all after the same employee. The reason why I do that is because I want to show you kind of how the numbers evolve when we actually execute them. And now let me execute this again in breadth first order. No, this time it's breadth first order. So as you can see, you have now 1 dot minus 1, 1.0, 1.1. This is just since I have now inserted between 2 values, and previously it was 1 and 2, I now obviously cannot just come up with a new number, so I start saying 1.1, 1.2, 1.3, and if I insert before 1.0, I still have to do, so I start numbering negatively. So this is just a way of keeping these numbers insertion stable, meaning that I don't have to go and renumber all the other columns simply because I insert something before something else. Now, if you remember how to write transitive reports, like who are all the people who transitively report to person X? If you have a parent-child table, that's quite a pain. You have to do a recursive query. It's not that easy to do. We have recursion in SQL Server 2005 using common table expressions, but it's not that easy to write. In this case, it's pretty simple. I do find all my transitive reports of employee ID 2 by simply looking at whether it's the node that I'm looking for is a descendant of my employee. So this query gives me back 2 employees. One is myself, and one is my report. This was done with a simple scan. Okay, this is kind of giving you a little bit of an information about how hierarchy ID can be used to manage this functionality. Now let me quickly recap in more detail again what we have seen. Sparse columns is a storage attribute on a column. And we will do storage optimization such that we don't use any byte for null values. It also collocates data on the page, which gives us performance benefits. And we have changed the TDS layer to support null compression. So it's not only on the storage layer that we have to do optimizations, it's also when we move the data back from the client to the server and from the server to the client, where we want to make use of the compression. Otherwise, we would have to explode it into the existing null values, which take space, and then you have less performant transport. However, there's no change in query and DML behavior, as you have seen. And this is just a recap of some of the syntax. So how do we actually store that? If we have non-sparse storage, you have null values and you use space for every single column that you have inside the database. Now, if we do sparse storage, you basically have these sparse vectors that just identify the properties and their values that are being used, and for everything that is not being used, we are not using much space. However, there is a slight overhead that we use to indicate that this is sparse storage. So there are a couple of bytes that are getting used at the beginning. But if you have more than 1 or 2 sparse columns, normally the space saving is already there. Now, if you have sparse columns, you want to have the ability to have wide tables. And that's a feature that we are currently working on to add support for more than 1024 columns for the sparse columns. And we also then allow you to have multiple, I don't know, thousands of indices to be able to have indices on your sparse properties. Now, if you want to get the ability to work with sparse columns in kind of a set way, we are giving you the ability to have sparse column sets. Now, the sparse column set, as I mentioned, is a specific untyped XML data type instance. However, it is not using the same XML infrastructure behind it as normal for storage. It's actually just a view over these sparse columns. And it's updatable, as we have seen inside the demo. Filtered indices and statistics, we have seen, allow you to basically reduce the amount of data that you index in the table and give you, therefore, smaller index sizes and potentially better performance in going through it. And the query and DML optimization is basically using that information to do cost-based optimizations on that. Current restrictions are that the predicates that you can specify on the filtered index are simple value comparisons with greater than, less than, equal in a conjunctive form, like the one that you have seen in the example. You cannot invoke, for example, an XML data type method on it, or you cannot do arithmetic in it. You can only do simple comparisons. And it only works on non-clustered indices. So here's, again, a visual example. I think we have seen the example during the demo. So I'm just quickly pointing out here that you obviously can have more than one of these filtered indices on your column. In the hierarchical data context, Some of the scenarios where you might want to use the hierarchy ID is that you have things like lists managements that are hierarchical, that have threads going through them. You have organizational charts. You have content management categories where you basically have taxonomies built up inside your database, et cetera, et cetera. Now note that the hierarchy ID type itself does not guarantee on the column that you have a completely connected tree or graph stored. That's something that you have to do yourself. We just give you a building block. Now note in SQL Server 2005, already mentioned, the way of actually dealing with hierarchy data is parent-child column or XML data type. This is a third way of dealing with it, and it's now up to the scenario of how you want to use it. For example, if you want to keep everything, the hierarchy together, use XML if it comes in XML form. If you, however, want to decompose it and you want the ability to have this clustered mechanism of not having to do lots of recursive queries to get transitive closure or this sentence, you might want to use the hierarchy ID over the parent-child column representation. So in terms of implementation, it's a CLR UDT. It will be provided on the client side as well using the assembly that also contains the spatial data types. It's implemented as a var binary. It's as a small UDT. It's not a large UDT. It's a var binary encoding that is less than 900 bytes. Well, we know already it's used for position in the hierarchy. It logically encodes the path. So here's a visualization of the numbers that we have seen. It is logical, what you would expect. It has rich built-in methods for manipulating the hierarchies. We have seen some in the demo, and I will show some more on the next slide. Yes, please. Can you repeat the question, please? Yes. Okay, so the question was, in the example that I've shown when I was inserting in between, for example, 1, 1, and 1, 1, 1, 2, I had something like 1/1.1/. And the question was whether there is a built-in cleanup function that basically goes over it. And the answer to that is no. However, I think you probably could write something like that. But I don't know why this would be necessary, because unless you have, yeah, okay, yeah, and there's probably some limit of numbers that we can get to at some point if you have really bad insertion behavior, for example. That's maybe good product feedback to the product team on that. Now, as we said, it simplifies the storage and querying. Note that the data type is designed such that the ordering using the normal less than operation actually gives us depth first order, and that we have arbitrary insertion and deletions. However, talking about deletions, if I go and delete, for example, /1,1 out of the tree, all its descendants will not get touched. So you just have a hole inside your tree then. Now, the ordering still holds. They're still direct descendants, so but they are not considered siblings of 1,1. So the rehoisting you would have to do yourself using some store procedural logic. Here are some of the methods. So you have obviously get root that we have seen, get level. You can reparent. So you have support for reparenting. You have to call that out explicitly, however. You can check for descendants. You can serialize it. You can parse a string. You can read and write binary representations. And you have ancestor and descendant information. Note that, however, what you don't have today is an easy way of getting a hierarchy ID out of the probably most common way of getting hierarchical data into the database. What would you use to put hierarchical data into the database today? Excuse me? Yeah, path expressions, yes, but if you have data, like if you give me a whole bunch of parts lists that you get from your business partner, you're probably getting it today in an XML format. And XML already encodes the hierarchy information. But unfortunately, at this stage, we don't have the functionality yet to convert that easily into a hierarchy ID. I'm working on adding that, but it might be, so getting kind of customer feedback on that might be useful. Yes, please.
It looks like that it would be possible to implement hierarchy ID also for server 2005. For example, you get listeners, open context connection, query, and so on. Is this implemented in this way also as per server 2008, or are there any optimizations happening in query processing?
Yes.
That get descended or get level don't have to do queries by themselves?
Yes. So I think if I paraphrase your question correctly, is are there any implementation details for this new type that makes it impossible for using the assembly in SQL Server 2005? Is that correct?
No, my question was, does the query processor, the one that applies the query to a plan, knows the semantics of query ID? For example, that not get descended also sets query.
Okay.
So if I implement hierarchy ID, I would do so. I would open a context connection and say get descended, I query my children, and
yeah. So the query processor, I don't think at the moment has any specific knowledge about the type. However, we have mechanisms, since this is this hierarchy ID representation, which is very similar to what we use in the XML case, we could actually use some of the kind of try statistics that we use in that context to actually give you some additional hints and so on. And I think we are looking into that. But at the moment, I don't think it's part of the product yet.
so if I take a look at the execution plan, I will see various statements.
You basically will see the invocation of the CLR methods, yes. Okay, to summarize on time, SQL Server 2008 will make it even easier to manage and create applications that deal with unstructured and semi-structured data. I hope I have convinced you with showing you all this new functionality that this is possible. The main approach is that we try to minimize the cost of managing all types of data by making it available inside the database, so you only have one backup and restore that you have to do, etc. It also simplifies the development of applications that combine relational and these non-relational types of data. And we extend services such as concurrency control, locking, etc., to logging to these non-relational types of data as well. I would like to also point you to some other presentations, all of which already have passed, unfortunately, that also deal with unstructured and semi-structured data. Since they have passed, you can now download the video soon. I encourage you to download and use the existing and subsequent CDPs, especially the next one will have lots of the information. Not all of the functionality that I've shown you will be in the next CDP. Some of that will be in the CDP after that, like sparse columns, for example. In order to be able to reach me, contact me through my weblog or come up and get a business card. I appreciate your attention. If there are any more questions, we still have a couple of seconds. Maybe use the microphone. Otherwise, I will stick around a little bit. Okay, there's a question here.
Regarding the unstructured data query context search, we are dealing with structured data. You expect to receive a Boolean result regarding the rows that match the query.
Yes.
When you move to unstructured data, Boolean result is not enough. It's not enough to say that this word contains in the text.
Yep.
I want to do the scoring.
Yes. So the question was, as a summary, if you query unstructured data, often exact match queries, where you get a Boolean result, yes, it's true, or no, it's false, is not sufficient. You actually want to get a scored relevance result, which says this is the most likely to satisfy the search, and this is less likely. And the answer to that is that already in SQL Server 2000 and 2005, our full-text search capabilities gave you the ability to do scored search over your unstructured data over which you build your full-text index on. So we already have this capability, and this is not going to go away, obviously, in SQL Server 2008. So the next question then is if I have scoring, often the determination of the relevance is an algorithm that is kind of hidden from the user. And the question was whether we can go and affect that scoring in some way. And the answer to that is not at the moment in this release, but we are looking into providing you with ways of either adding weights or even potentially at some point make scoring pluggable. But that's something that is not in product planning yet. That's something that we're looking at. And so if you have any specific requirement, I would recommend you to send me an email, and I can move it into the product team as another data point for them to consider. And I see the people getting nervous and flashing here. Take one last question, if you don't mind. Yes, please? Can you add? Yes? You want to promote the property out of your XML into a relational column? Yes, you can do that already today in SQL Server 2005 by applying a value method with a path expression in it that extracts the value out. And then you have different mechanisms of storing that. I did that actually. I showed some examples earlier in my previous interactive session where you basically then either promote the property out when you load the data, or you have a computed column that is persisted that basically does that for you. So yes, you can do that. And then you can also define your filtered index on it, for example, if you want to, or your non-clustered index. Excuse me, I couldn't hear that. Yes, you can do it on a sparse column as well. It's not any much different. It's just the way that it's getting stored is different then. Okay. I appreciate your patience, and I wish you a happy day. And thank you.